Good afternoon. What you're looking at here is PCB 2 of the 15.6 inch Libre laptop. We have here a disassembled chickeny keyboard matrix, which for purposes of reverse engineering, it was impossible to determine which of these 24 pins were row and which were columns. So unfortunately it had to be destructively dismantled. That having been done, we're able to identify that these are this is row 1, row 2, column 1, column 2, column 3, row 1, etc., rather than the more intuitive arrangement which you might expect, where this would be row 1, 2, 3, 4, 5, 6, 7, 8, and then the remaining ones columns. What we're doing on here is, this is an STM32F072 underneath this connector there, which is carrying out 8 GPIO outputs, each in turn. They are open drain, so that there is no feedback between things. So if somebody presses like 4 keys, which happens to be on the same columns and same rows, normally you'd not be able to tell that those which of the keys have been pressed, especially if you only just do 3. You cannot actually tell if the 4th one is on or off. So if you've got the feedback between things, but if you've got open drain on the outputs, then you can at least, you have only the one row. It's complicated. I'd never realised that keyboard design was such a radical piece of engineering. Amazing. So what I've got set up here is a dual endpoints on USB from this single device. So when you plug this in, it appears to be both a USB CDC ACM modem and a USB HID keyboard. Now later that will be 3. That will be a USB HID keyboard and a USB HID mouse. So we have 3 separate endpoints. The reason for having the CDC ACM is because you need to do status information. Now let's have a look here. We've got it plugged in. Let's move the mouse up there. This is a standard USB HID dump command. And if I press one of these jobbies, let's press the escape key. Keyboard events, yeah, and it does actually support multiple keys presses. And then on the minicom command T2I ACM 0, if we start pressing keys, we can see that's just the standard echo thing from the USB CDC ACM example that comes with libopenCM3. So the reason for having that status information there is because we've actually split these into 3 circuit boards. This is the middle one that controls keyboard, and on this connector will be the touchscreen. That USB connector will be replaced with hard wires into the USB port on the main laptop board, and a few GPIO such as the power button and power on, also the reset and boot firmware flash mode from this board will be set so that all the programming can be done from the main laptop board itself. Now once obviously this is hardwired, this cable, which is the USB which is going to a development laptop, cannot be plugged in. So it's unfortunately the battery control has to be done from the laptop, so I have to get a rudimentary battery charging mode set up here in software before I can assemble the laptop, because once it's assembled, if I need to do any development using the laptop, I need to undo all the soldered wires. Here is the battery board. So what will be happening is, if you want to check the status of the battery or put the laptop into charge mode, you'll need to do a CDC command, which will be from the laptop itself, using the EOMA68 CPU card. That will then go over USB CDC ACM to here. This will then do an I2C command to this, which will then put the laptop into charging. This is just for the preliminary thing, because the linear LTC4155, turns out that linear lied on the datasheet. It was totally misleading. I do not recommend use of linear products because they farmed off everything. Long story. But this is going to be replaced with a Texas Instruments BQ24610 or 24162, I think it is, something like that, which is a much better battery charging device. Yeah, that's basically it. I'm almost at the stage now where I'm going to be putting this together, those 3 circuit boards, that laptop one. I just need to finish off a rudimentary firmware first of all. I thought you might appreciate seeing that before it goes into gets all put together. Thank you very much.